Black holes are one of the most fascinating and enigmatic events in the universe. They are enormous entities with a mass between 2 and 4 million times the Sun's, but at the same time, they were virtually invisible to us. Up until recently, we had very little knowledge of them. However, thanks to the research over the last 2 decades, we have learned more and more about these enigmatic objects. Michio Kaku recently made a significant announcement, a discovery. We have managed to find out what is contained within a brand new black hole. This information has shed light on particulars that might have gone unnoticed in the scientific world. We have entered the secrets of black holes and revealed these mysterious spaces. If you're interested in keeping up to date with information about the universe and its surroundings, subscribe to our channel, be certain to enjoy this video, and activate notifications. Despite the fact that many of us have a general idea of what black holes are, there are still a few holes in our knowledge. In 1916, Albert Einstein published his relativity theory, which predicted the existence of black holes. Black holes were a new concept at the time, purely theoretical, and needed to wait another 50 years for the scientific community to find evidence of their actual existence. This event occurred when scientists in the 1960s were studying the constellation Cygnus. During their investigations, they discovered a bright blue star that emits X-rays. They discovered that the X-rays in question weren't moving independently, but they were drawn to a massive black object that the star was orbiting. This is how the term black hole was given to this discovery. It was important because it provided tangible evidence for the existence of black holes, demonstrating that they were not only slivers of Albert Einstein's imagination, and it also showed the existence of a magnificent entity in space that we urgently needed to investigate. This black hole was named Cygnus X1 and is located in the Cygnus constellation at a distance of about 6,000 light-years away from Earth. This was a significant discovery because it had extremely high density, giving it strong gravity. Researchers carried out the search for additional black holes and discovered that there could be around 100 million of them in our own galaxy, the Milky Way. However, due to their extreme difficulty to detect, we continue to not have a precise number. Several million black holes in our galaxy make them very important areas of research. The main concern of black hole research has always been their gravitational attractions, so intense that anything that comes into their path will be astronomically compressed into a singularity. Black holes behave like cosmic vacuum cleaners, sucking in everything in their path. One of the most disturbing aspects of black hole research is that if someone were to fall into one, they'd be strained to the point of reducing to a single line. This process would occur slowly, and the person would die before the final form is established. Therefore, it is safe to say that no one should venture into a black hole. However, because of the presence of these things everywhere, questions and concerns arise as to whether we are really in danger, even though the closest black hole to Earth is 1,500 light-years away, which is still close enough to raise questions and concern that in 2021, scientists managed to make the first clear picture of a black hole, specifically of the black hole M87. For several consecutive nights, photographs of the black hole were taken, and with each image, researchers collected more evidence about it. It was essential to combine the individual photographs to obtain a complete image that filled in all the gaps. In this way, scientists discovered that black holes are not just simply an empty hole in the void, as many people believed. In reality, they are much more complex. To reach the empty part of a black hole, it is necessary to traverse 3 previous layers. The first layer is known as the event horizon, which is the point of no return. Once the event horizon is crossed, there's no turning back. The second layer is the photon sphere, which is the region where light orbits around the black hole. Any light that enters this area will be trapped and will not be able to escape the gravitational pull of the black hole. Finally, the third layer is the singularity. This is where everything that enters the black hole is astronomically compressed into a point of infinite density. The singularity is a point in space-time where the laws of physics, as we know them, break down. That you're probably wondering what lies beyond the third layer, also known as the singularity, right? The idea is that instead of being crushed fully into a black hole, one would be sucked through a tunnel, through the ring of fire, and emerge through a white hole somewhere. This tunnel, which also exists in a parallel universe, is known as the Einstein-Rosen bridge, or wormhole. This theoretical bridge is a passage through space-time that connects 2 distinct parts of the universe or even 2 parallel universes. To understand how this works, we must understand the concept of space-time. This is the basis for Einstein's theory. Space and time are not separate entities but are connected, forming a 4-dimensional fabric known as space-time. Massive objects warp space-time, creating a field of gravitation that affects the motion of other objects. To visualize this, we can imagine a sheet of paper representing space-time. If we draw a line between 2 points on the paper, we are representing how things move through spacetime. Now, let's consider folding the paper in half and creating a shortcut between those 2 points. This basic idea is what is known as a wormhole. Shortcut through spacetime that could, in theory, allow for faster-than-light travel or even travel between universes. The concept of a wormhole is still highly speculative, and while it is mathematically possible according to Einstein's equations, there is no observational evidence to confirm their existence. Scientists continue to study the possibility of wormholes, as they could unlock answers to some of the universe's greatest mysteries, including time travel and the nature of parallel universes. Black hole research has also revealed other fascinating phenomena, such as Hawking radiation. Proposed by physicist Stephen Hawking in 1974, this theoretical process suggests that black holes are not entirely black but emit small amounts of radiation due to quantum effects near the event horizon. This radiation could cause black holes to slowly lose mass over time, eventually evaporating completely. The idea of Hawking radiation has revolutionized our understanding of black holes, showing that they are not eternal but have a finite lifespan, albeit one that spans billions or even trillions of years. Another intriguing aspect of black holes is their role in the formation of galaxies. Scientists believe that supermassive black holes, which reside at the centers of most galaxies, including our Milky Way, play a critical role in galactic evolution. These black holes, with masses ranging from millions to billions of times that of the Sun, influence the orbits of stars and gas clouds, shaping the structure of galaxies. The supermassive black hole at the center of the Milky Way, known as Sagittarius A*, has been a focal point of research, with astronomers capturing its first image in 2022, further advancing our understanding of these cosmic giants. As technology advances, our ability to study black holes continues to improve. The Event Horizon Telescope, a global network of radio telescopes, has been instrumental in capturing images of black holes, such as those of M87 and Sagittarius A*. These images provide unprecedented insights into the behavior of matter and light near the event horizon, testing the predictions of Einstein's general relativity in extreme conditions. Future missions and observatories, such as the planned LISA, Laser Interferometer Space Antenna, aim to detect gravitational waves from black hole mergers, offering another window into their mysterious nature. Despite all these advancements, black holes remain one of the most perplexing phenomena in the universe. Questions about what lies beyond the singularity, whether wormholes exist, and how black holes interact with the fabric of spacetime continue to challenge scientists. The study of black holes pushes the boundaries of physics, blending the realms of quantum mechanics, general relativity, and cosmology in ways that could one day lead to a unified theory of the universe. If you're fascinated by these cosmic enigmas and want to stay updated on the latest discoveries, consider exploring more resources or subscribing to scientific channels dedicated to astronomy. Black holes are a reminder of how much we have yet to learn about the universe, and each new finding brings us closer to unraveling their secrets. What do you think about black holes? Are there specific aspects you'd like to dive deeper into? A shortcut or connection through spacetime that joins two distant points in the universe. Wormholes sound like science fiction concepts, but they are actually a prediction of the general theory of relativity. None have been directly observed so far. The reason for this is that wormholes are inherently unstable and would collapse almost immediately. However, in the event that a stable Einstein-Rosen bridge were to exist, it signifies that black holes are not just cosmic devourers but also portals that could link us to other parts of spacetime. The question then arises, could we use a wormhole to travel through? Despite the fact that this is still the subject of speculation, and it has not yet been determined whether the theoretical possibility of wormholes allows for exploration, fascinating concepts about interstellar travel and the link that exists between different parts of the universe arise. What do you think about it? Do you think wormholes are mere speculation? I hope you enjoyed the video. Don't forget to hit the like button and subscribe to the channel so you don't miss more content like this one. See you in the next video, and thank you so much for watching as we continue delving into the depths of our universe. Black holes continue to be one of the most compelling frontiers. While we've made incredible strides in understanding what they are, how they develop, and the effects they have on surrounding matter, there is still so much we don't know. One of the most intriguing inquiries scientists are now asking is whether the use of black holes as a type of energy source is possible. Some theories suggest that the immense forces of gravity that surround a rotating black hole could be harnessed to generate energy. This idea, called the Penrose method, suggests that if we could send matter into the region just beyond the so-called event horizon, we might be able to extract energy from the rotation of black holes in the ergosphere. While this remains purely theoretical for now, it opens the door to amazing possibilities for future space technology. Another avenue of research is the Hawking radiation predicted by physicist Stephen Hawking. According to this theory, black holes are not completely black. Instead, they emit tiny amounts of thermal radiation due to quantum effects near the event horizon. Over extremely extended periods, this radiation could cause black holes to slowly dissipate and vanish. If we could directly observe this phenomenon, it would offer useful insights into how quantum mechanics and gravity interact, possibly leading us toward a unified theory of everything. Additionally, black holes may play a much larger role in the formation and evolution of galaxies than we ever imagined. At the center of nearly every significant galaxy, including our Milky Way, lies a supermassive black hole. These giants can be billions of times more massive than our Sun. Scientists believe that the gravitational influence of these black holes may help regulate star formation and control how galaxies grow and evolve over billions of years. With the assistance of powerful new tools like the James Webb Space Telescope and the Event Horizon Telescope, we are just beginning to peel back the layers of these cosmic giants. Each new finding raises more questions, pushing the boundaries of what we know and challenging the limits of human comprehension. The road to understanding black holes is about more than just science. It's about seeking meaning among the vastness of the universe. Are they entrances to other universes? Could they assist us in comprehending time travel, or are they simply the universe's way of recycling matter and energy? We may not have all the answers yet, but one thing is clear: black holes are no longer just the stuff of science fiction. They are real, they are powerful, and they hold some of the greatest secrets the universe has to offer. So, keep an ingenious mind, keep asking questions, and never stop exploring. If you enjoyed this journey through the universe, don't forget to give the video a thumbs up, share it with fellow space enthusiasts, and subscribe for more mind-expanding content. Until next time, keep looking up, and remember, the universe is always listening.